Yes, but no, also the most of the time though.
Most of the time.
Yeah.
No.
Hey man, we've done stupider things.
What about you, Herman?
I'm going to Miami.
Miami.
Oh, Miami.
He's
Yeah.
partying.
So you were sending to Miami?
He's partying with Joy Lee, Ron.
How will you go to Miami?
We will go to Raleigh and from there we will fly to.
Okay, if you drive, I can take you to Orlando. I will drive to Orlando today. I have a conference in Orlando today.
Hey.
But still,
Whoa.
you have to take care of yourself from Orlando. to Miami. Yeah, I can't drive further because that's crazy. It's already 8 hours from
Yeah.
here to Orlando to Miami, probably like 12 hours, something like that, or 11.
Yeah,
That's crazy.
It's 12 hours driving straight.
yeah.
12 hours, right? So I don't want to travel for the last 4 hours. I can count for the first 8 hours, but for the last 4 hours. What about you guys?
Are you going to
Any plans?
On Asheville.
Actually, it's a short driving, like 4 hours, right?
Wow.
4 hours. Where you visit Smoky Mountain or
Well, that's Blue Ridge.
Blue Ridge? Okay, okay, that's great. This console.
What conference do you have?
I will attend. This is not a research conference. This is the first teaching conference I will arrive. Oh, sorry, I will attend. It's the how do you say? It's the online teaching conference. So because online teaching now is anything wrong with the online teaching is a trend.
Yeah,
so I think we have to learn more about online teaching. Wow, you guys now are face-to-face session. I personally definitely agree with most faculty's opinion that face-to-face session is much more efficient than online session. Much more efficient. I'm not sure whether you guys have experience to take online class, but face-to-face, if you stay here 3 hours per week, probably you only need to spend 1 or 2 hours in the rest of the week to cover all the content you have to review. But online session is hard. Even we have a class video every time, we do have some students really watch our class video. So what have you taught in this session? Wow, online students they do watch. So, but still, there's no easy communication, right? Like for example, you can ask me questions, interrupt me anytime if you want. If it's appropriate, right? If you're relevant question, but online session different. Okay, student kind to be shy to ask questions for online session. What's happening here?
That looks like a picture
Yeah.
Looks like we just
above. What does it say? PowerPoint not what?
It says it's ready for fall break.
Because
What's the only one?
Get this set out of the room.
The computer's not
Outside of the
working.
room, so screw it.
that's just a shame.
Balling. I'm trying to tell you, Professor.
Oh,
to tell me
Uh,
what do you want to tell me? Now you can tell me now. It's the time.
I can't.
Tell me.
I can't say nothing.
So you can only say you are wrong, right?
Yeah.
That's fine. So basically, online teaching is a trend, but we have to learn how to improve the efficiency of online training. Because you guys, think about you guys after you graduate, well, even you take MBA degree or other degree or later professional certificate later, then it's hard for you to come back full time to the school, right? Especially like 10 a.m. session. It's really hard for the weekday. And in the rest of our life, a lot of learning must happen online. It's hard for you. Some maybe you go to some good MBA program and still become a full-time student, but for some other online training certificates, right? So we have to learn how to improve the education quality or training quality online. So there's a lot to learn that. So that's the reason I want to attend this session. And hopefully we can bring some information back here. Okay, let's continue our study on chapter. By the way, I'll give back your case study by the end of today's class. Continue.
We're gonna sign attendance, or
Huh?
we're gonna sign attendance.
Oh, I forget. If you have a paper, please assign it. Anybody has a blank paper? Yeah.
Yeah.
Sign the name. It's very important today, right? You know, many students will
Professor.
lose the points.
Oh yeah, last week I didn't get the not the clipboard, the attendance sheet. To
Oh, really?
Yeah.
Yeah, just maybe come back to my office later.
Okay.
Maybe you mark here, say, I do attend last week.
Gotcha.
To remind me, okay. So, today's class, we will first continue our study to learn the ABC classification. So as we have discussed, ABC says you want to focus on the most important item for inventory management, like Walmart. We have discussion. I think Sam or somebody mentioned that electronic item are most important item for Walmart. So from the pure counts, probably only like 5% or 10% or even less than that for the all items held by Walmart. That is the cash cow for Walmart. So it's very important. B items, so medium important. C is not very important, but for the pure counts, it counts for 6% of inventory item. Now, before we can establish any policy for our items, we have to set our target service level. Right? A item definitely should have the highest service level targets, like 95%. B usually is kind of like 90%, 85%. C can be as low as 80%. So different service level require different inventory policy. We'll discuss later. So the A item only counts about 15%, but the revenue part is about 80%. It's B item. And C items, a lot of C items in Walmart, Food Lion, but they can only drive a little bit profit for the company. How to accurately keep our record? So I copied this page. No, this is not from our textbook. I copied this page when I take it from my the material I studied for the CSCP. So when I send you guys email, you probably pay attention that I say Charles Sean and then PhD, right? And then another thing is title is CSCP. If you guys pay attention to my email, you can see that my secondary PhD says. Anybody know what's that CSCP means?
Certified.
Specialist.
Good guess.
Computer programming.
Computer program. That's good guess. Yeah, I do know a little bit coding. I'm coding now. Use MATLAB. That's it. About my. It's certificate of supply chain professional. Okay, so this is certificate provided by APICS. I believe it's Association of Operations something. So this is a well-recognized organization, and the CSCP is one of the most recognized certificates in operation management or supply chain management. So in the future, if you really want to work on our field of operation management, supply chain management, this can be a certificate you want to get. So from the material, when I prepare the certificate test, so I find that's the one slide they have in the textbook. That's the trick, how to keep the record accuracy. I think it's very useful for us to learn here. So we want to keep our inventory skill, okay, neat, and make labels which can be easily visible, okay, for others. And use bin and spatial arrangements that make counting easy, okay. And definitely ABC category is very important. Technology, barcode, RFID, different technology can help you a lot. So that's what I've learned here. Okay, cycle counting. So cycle counting is the physical count of items in inventory. So it's physically a person go to your warehouse to count how many items you have, right? And often we use ABC analyze to determine the cycle. So usually for the A items, do we count more frequently for A item than B or C item, or less frequently for A items? What do you think? A items. More frequently counting than B or C, or less frequently?
More.
More frequent. Why, Jack?
Because you have less of it, but it's also the most sales on average, so you need to make sure that you're very accurate with what you have.
That's right. That's right. As Jack has said, because it's the most important since the revenue, right? So you want to have A item accuracy. Well, we know that's a problem if you lose item. For example, if you are shortage, you don't know that, and you don't we have, but you can't find that. Customer disappointment. Okay, if you have extra ones, you don't know. It's also creates problem. You order too soon. You say, oh, we are run out of stock very soon. But in fact, you still have 10 A items in the inventory. That can also create problem. So basically, A items are very important. We count more frequently than B or C items, and the target accuracy is also different. A items like usually is 0.2% error as most you can bear. B items 1% is fine. C you can see 5%. It's okay, right? Because well, it's okay. It's just okay. Not perfect. So then we need to determine when should we do the cycle counting, and who should do that. The second question we'll answer after a short example. A third one, what do you think? Who should do the cycle counting? Who should count the items physically?
Employees.
Employees. Usually, it's employees. Long time ago, usually we have consultants or professional people do that. Can you believe that? What's the hard part for the counting? But, well, probably 20, 30 years ago, they are really professional counter to count the books for you. But nowadays, usually it's work by our employee, but usually it's not a full-time job, like part-time. Okay, you count for 1 hour, and then the rest 7 hours you do some other job. So, and that's why cycle counting can be very useful because we are see you don't have to count every day. Here's the example. So one warehouse has 2,500 items in inventory. Among them, okay, I have to change the items here. This is not 500, so it's 250. Let's check. Because I used the old slide, remember? I can't open the new slide, so I have to use the older one. That's kind of a problem. This is 2012's one. 25. And 875 B items, and 1,375 C items. And then,
Got 1,000.
sorry, about this, I can blame.
Oh man.
I can blame whatever banana said. The PowerPoint problem.
Wait, can you go back to the error statistic real quick?
That's on you.
This one?
No,
It was like the 0.2 for
There.
A. There you go. Back.
That?
Yeah, one more.
Oh.
One more. There it is, yeah. I think.
that's the error, the accuracy error that we need.
That's right.
Yeah.
0.2%. Basically, if you will have like 1,000 items, so you can only fill positive 2 or negative 2 for items. If you count 1,002 or 998, it's fine. But anything beyond that, it's not acceptable for you. It's just a general threshold. It definitely depends on your industrial company, but you generally you can see basic idea. We want to differentiate. We have different criteria for A, B, C items.
Mm-hmm.
Okay. Good for you? Okay. Now, let's count. Let's do the count work. So we have total 2,500 items in the inventory. Among them, 10%, 250 are A items, 875 are B items, and the rest, 1,375 are C items. The manager wants to count A item every month because they're so important. So 20 working days. So which means, okay, if that's one A item, it counts once per month. And you count another A item once per month. This doesn't mean you have to count every day, but you have to count them at least once, also as exact once per month. For B items, the requirement is lower, only counts once per quarter, which means 60 working days. Okay, we count 1 B items. Okay, then we cover all B items in this quarter. And the C items each 6 months, which is 120 working days. Now the question is how many items are counted per day? Since you have to count some A items per day, also some B items in a day, some C items a day. So we have to first calculate the number of items counted per day for A item, B item, and C item. And then add together, you can tell me, okay, if you do the job, how many items you have to count per day. Any questions before I give you time to do that? Pretty straightforward, right? Okay. You guys 3 minutes should be done. Do you have pen or pencil? Don't have that? Don't have anything. Oh. What's a good performance?
All break.
Senior writers right here.
Borrow some pen or pencil. We have a lot of examples to do in this class.
I'm for detail.
That's
No idea? Yeah. It's an easy question. That's easy?
How many
items are counted?
Yeah, 1/4. This is 12 months.
12 to 8 by 4.
Take the time.
No, you might be right. Yeah, you're right. I was thinking
They count every 2 days.
days.
Every quarter, every 60 days.
What do you want? What do you
Well,
get?
man, I guess you could. Like,
Okay.
just do-
That's great.
Yeah.
Very simple, right? Some students think in the hard way, so they can't get solution.
You only count.
Yeah, that's gotta be it.
It's really only require elementary school maths, right? Maybe less than, right? If you have finished that, maybe less than 4th grade. I don't know. I mean, it depends on school, but we have to think in a simple way. Don't make it complex. Just focus on elementary school maths. That's your guess the results. If you think about high school, you won't guess the results. Get that? Elementary school? Okay.
Just elementary school math.
Yeah.
One of the 2 things that we can do. Do it.
Don't make it complex. I think many people already finished that, right? So let's teach the first class, math class in elementary school. How to do that? Any volunteer? High school kids can't be volunteer. Okay.
I'll try it.
Okay.
250
So for the first one, A items 250.
divided by 20.
Yeah.
Yeah.
You guys
13. What?
something like that. 30.
Yeah.
Okay, let's say 30.
Rounding it up to a whole number.
13 per day, right?
Yeah.
B is equal to
875 divided by 60.
you got what?
15 per day.
Yeah, I was like,
Per day.
Yeah.
What about C?
I'll be 12.
1375 divided by 120.
Mm-hmm.
And that gets you 12.
12.
days.
So what's the total amount?
You gotta add all of those up.
Okay, I didn't math, right? So it's
yes.
28.
So 40, is it 40 per day?
Okay. Yeah, as the teacher, I also have to remember the elementary school. So you can see that's really straightforward. But it can tell us, you can see that. We can observe that, okay, we use elementary school maths, we can solve that, but probably we are still in elementary, we don't understand what does this mean. Now we can understand. You can see that A items only count for 10% of the total items. But in fact, if you see how many items will count per day, they're very close to each other. We count 13 items per day, 15 item B, 12 item of C. So they're very similar. The reason that we have to count A item more frequent. Even it only counts for 10%, but we count a lot of I items per day. C item, we have a huge amount of C items, but the frequency is small. Then every day we count even less C items than A items. Together, we only need to count 40 items per day. And then every month we count all items. Every half a year we count all C items. So that is like pastime job. Is that clear for you for the cycle counting? Question? It's clear? Which means, okay, something where I have very strange question asked me before about something. Why you didn't count all items every day? Some question like, how can you count 40 items and then you get accuracy? Is that because you shouldn't count every item per day because it's a waste of time, right? But since 258 items has to be counted in 1 month, so which every day we only need to count 13. At the same time, we also need to take care of B or C item. Even it's less frequently, we have to take care. And totally, we have count 40 items per day. So, okay, that is the simplest example in this chapter. All rest example are not so simple. Okay. Good news, right?
Is it a homework problem? Is this
No.
Oh.
Already give you a homework question. Have you guys paid attention? Right.
Yes.
All right.
Yeah.
Since some of you guys maybe don't want to sleep in the full break, yeah, I understand, right? Not like Jonas. That you don't want to sleep. That's the best time thing. Kill your time. Just do the homework, operation management, right? Definitely kill lots of time without get the result sometimes, right? Anyway, so cycle counting. Cycle counting is in that way. The reason we want to do cycle counting is we want to remove our error, right? If we have find the difference between our counting and in the database, then we correct the database. Say, okay, in fact, we only have 1,000 on hand. The database show 1,020. There's something wrong. So if we find the error and explore why it's happened, well, we have a lot of things to explore. If you remember, that's the slides I get from the CSCP preparation. Whether we keep it secure, leads, label easily visible, there can be a lot of reasons beyond this list. Okay, we explore the reason, right? And identify the cause, and eliminate the cause of error. Maybe the skill reason, somebody really steal the book from the library. Well, that can be a problem. And then we have to eliminate the cause of error. Continuous improvement. That's the purpose of cycle counting. Because we know before we introduce any inventory model, we have to know exactly what we have, right? That's the fundamental. So if we don't know how many we have, no matter how fancy model you told me, I can't do a good job on inventory management. Okay, I don't know when should I order because I don't have no idea how many on hand. So that's the problem. So it's a fundamental thing we have to solve before we go to any inventory model. Okay, let's say now we have very good accounting procedure and then we know very sure about how many inventory we are on hand anytime we know for sure. Next is we want to know how much to order, right, and when to order. The first model we introduced in this chapter is the EOQ model. Has anybody heard this name before? Raise your hand. Nobody. Okay, that's great. Right, because that means okay, you will know that after this class. So EOQ model is the economic order quantity model, which can identify the optimal order quantity with the goal to minimize the summation of the annual cost that consists with the order cost and also order size and the frequency. We have three different types of EOQ model. The first one is the basic EOQ model. Usually we call it EOQ model. The second one is the economic production quantity model, EPQ model, we'll discuss. The third one is the quantity discount model. So let's first look at the basic EOQ model. Basic EOQ model, even nowadays, still widely used in a lot of industry. The reason is pretty straightforward because it's very simple to implement, and it also can give you very good results. Okay, if the case is close to those assumptions. So the goal is to minimize total annual inventory cost, okay, to find a fixed order quantity. Because we do have a lot of assumptions if we can use EOQ model. First, only consider one product. It can be easily extension to multiple products. Simply speaking, you just implement EOQ model for multiple products, right? I calculate the optimal order quantity for item 1, and then use EOQ for calculate the optimal order quantity for item 2, and so on. So you can consider one item per time, right? And then second assumption, annual demand requirements are known. Who can explain this assumption for me? Annual demand requirements are known. What does this mean?
You have a good idea of what you're going to sell or how much you're going to sell.
Forecasting.
Forecasting. Both of you are correct. You have very, very good forecast. Ideally speaking, it's 100% accurate. But if you have good enough, you can think about you are satisfied this assumption, right? Annual demand, you know in advance, definitely. If you know the past demand, that's useless, right? You know that's in advance. It's a forecasting. Demand is even through the year. That can be a hard assumption. We talk about seasonality. All items that have strong seasonality can't satisfy the third assumption. The basic EOQ model can't be used for any seasonality items. But if your item has very stable demand, like how do you say, the chicken wings. I don't know chicken wings demand is chicken. I really like chicken wings. Probably too many times I mentioned chicken. Water. Okay, water demand is pretty stable, right? Soda is also pretty stable, right? So if you have the demand like this, probably you can use this one, right? EOQ. Lead time, another strong assumption. Lead time, if you remember, is the time between you place order until receive order. We know that if you place the order, your supply is far away from you or they have some issue, most likely lead time has the fluctuation. It can receive 1 day, 2 days, 3 days, even 1 week. But let's say your supply is your labor, very close to, have very good relationship, partnership, then you have very stable lead time. Every time you place the order, you receive the next day, right? Okay, each order received in a single delivery. This can be easily satisfied. Okay, if they can satisfy in a single delivery. No quantity discounts. If your order is pretty stable, most likely you probably don't have the quantity discounts. So, as we discussed, many items can satisfy the certain assumptions here, and then we can use EOQ model to determine the optimal order quantity. Visual demonstration about the EOQ model. So when you are in the position like the retailer store, you have the convenience store, you have to determine, okay, how many you want to order, the quantity you want to order for these specific items every time. And then how to determine that? We'll discuss that. But anytime, if let's say you say, I want to order Q, that's the quantity I order every time. Okay. So after you receive the order, that's the beginning point. You receive the order here. You have your on-hand inventory is Q, right? That's your inventory level, Q. And then you can see this is a straight line. This is your inventory level. Go down. It's going down, continue going down, right? My first question here, why this inventory? I know the inventory level definitely will go down because we have customer consumption, right? It's good news for us. But why it goes down in a straight line? Why is it not curved? Why is it a straight line?
The demand forecast?
No demand forecast. We have assumption here to make sure it's a straight line. Which assumption?
Demand is even.
Demand is even, that's correct. Which means demand is stable. So every day we have the same demand. So we have the slope here, which is the daily or whatever monthly demand, right? The slope here. So given the even demand,
Sorry, can you go back? Well, why wouldn't it be number
3.
five?
Number
Why-
5. Number 5, you just say, okay, number 5 is like this way. If you receive the order in multiple delivery, you have this problem. You know, think about it. So if you place the order of Q, well, but one time you only receive like half a Q, and then the other day you receive another half. So you are something like this, right? You receive 2 delivery. That's number 5. But when we talk about the straight line here, it means, okay, you receive this Q in 1 delivery, right? But the consumption rate with the demand rate is constant, which means
Okay.
you have a straight line.
I
Clear?
see. Okay.
Clear? Okay.
Alright.
We understand why it's straight line. Then you understand, in most situations, if you draw a picture of inventory level, it's the curved one, because daily demand is different, right? But here, okay, let's say you have very stable demand, straight line. And then, this question we'll answer later. You have to place the order. That's the time you place order. When you still have some inventory, why we can't wait until the last minute to place order?
Because I mean, it takes a while for
Lead time.
Yeah.
Yeah, it has a lead time. If the lead time is not 0, most time lead time,
Yeah.
how can you have a lead time 0, right? So you have to place the order before you reach the 0 inventory. Makes sense, right? That makes sense. Unless you use some like just in time or zero in theory, that's a different story. But most time we place the order before we run out of stock. When should we place the order?
Said where?
When? How to determine these points?
Well, you would subtract, those two
Lead time.
values. to
Two
get
value, which two value?
that.
Let's give an example. Very simple.
Right,
This is
okay.
beyond the EOQ. Let's say your daily demand is 10 units per day, right?
Right.
10 units per day. And every time you order a weekly demand, so you order quantities 70, which can cover 1 week. Let's say very simple. You every Monday you get a new order. Okay. And let's say your lead time is 2 days. So it means you place the order. Let's say you place the order on Thursday and you receive the order on Saturday. Clear, right? Now my question here is very simple. You follow the EOQ. The demand rate is constant. Demand is 10 per day. It's constant. EOQ definitely 1 item. And then, okay, let's say this Monday you place the order. When should you place this Monday you receive the order? So this Monday you have the 17. So this Monday you have 17 and the constant rates, the slope is 10, right? And negative 10. When should you place the second order here?
When you get to 50.
15?
I mean, when you get down to 2150 is sold.
Okay, tell me one number. You check inventory level. What is the inventory level will trigger action to place the order? Just one number. How many you have? How many will trigger your action?
21.
20. 21. I think you think a little complex. 20, right? 20 will trigger your action to place the order. Why is 20?
Because in the 2-day lead time, it'll get delivered to you to replenish your
That's right.
inventory level.
Because, as Jack said, we should place the order on 20 because 20 is the 2 days demand, right? We place order, let's say, on Saturday morning. Then we will receive this on Monday morning when our inventory becomes 0 after 2 days demand. So how to determine the reorder points in EOQ is very straightforward. Reorder points, ROP, is equal to lead time times the daily demand, which here is 2 times 10, which is equal to 20. This is too simple. The textbook didn't discuss this too much, but I want to explain to you that EOQ is very straightforward. Your lead time is fixed, demand is fixed, so it's lead time times demand. Then we should place order in this example is here, right? Anytime you see your inventory level is equal to 20, you place order. In fact, it's even more simpler because we know the demand is. We know all the information about demand and the lead time. Then we know every Saturday morning we place order, right? No surprise. And receive the order on Monday morning. So that's very simple to understand. So then we explain this reorder point. Now the only question is that Q. That's the question we have to answer. Given any Q, I can tell the reorder points. I can tell you all these things. But I need to know what's the Q. What's optimal order quantity? Here. Since our goal is to minimize our total cost, okay, we have 2 parts of total cost. First one is the annual holding cost. And when your items sleep in your warehouse, we have the holding cost, right? And the holding cost is very straightforward. Is H times Q over 2. Now, I will ask you, don't just follow the formula or just try to remember the formula. We have to explain the formula. We don't need to be mathematical school students to solve the EOQ or whatever. But why is Q over 2 times H is the holding cost? Well, H is the holding cost per unit per year. Well, that means if these items sleep in your warehouse for 1 year, we have H. But the really question is, why is H times Q over 2? Look at this graph. Why our holding cost per year is Q over 2 times H? Who can explain to us? Why? Why is Q over 2 times H? Volunteer? Brian? Or point finger to Jack?
I'll try to answer the question. What was it again?
So you will lose the participation points for today's class for sure, right? Without taking the pen or pencil and forget the question.
Really?
Anybody else know the question or know the answer especially?
Could it have something to do with that you never actually have full inventory, that you're always reordering at a point before you actually hit 0?
In EOQ model, you will hit 0, but the point you hit 0, you get the replenishments. So you hit 0 here, and you get the replenishment. So it's a very ideal model. You will get 0, but you won't get any stock out. Like your last customer gets the last item from you. Before next customer come here, you get a new order. But still, the question is why the holding cost is Q over 2 times H. Why is focus on Q over 2? Because we know H is the unit holding cost. But why is Q over 2? Can you remember?
That's half the
Any idea?
inventory.
What was
Q is the order quantity, right? It's the highest inventory level. Your order quantity is Q. Because anytime you receive the new order, you have 0 on-hand inventory, and then you receive Q. So Q is the highest inventory level, and then you have the even demand, and then come to 0 again, and you receive a new quantity of Q. So it's this graph. But my question is, why is Q over 2?
It's because as soon as you get it, there's inventory that's already being bought or left, since it's
What do you mean,
per
Jack?
day.
What do you
Like
mean?
in our example, if it's 20 per day
Mhm.
and we have 7 days worth, on the 7th day you'd be out, and it comes on the 7th day. As soon as you get on the 7th day, there'd already be inventory that's leaving.
Mhm.
So like divided by 2 is just saying that your inventory is basically cut in half every holding period. You're
Yeah.
not paying for that holding period because it's cutting like half of it's already gone.
That's right. That's right. The explanation is right, but mathematical speaking, why is over 2? I understand, okay, it's not Q, it's not 0. Why is over 2? You have to explain why is Q over 2 exactly. What does Q over 2 mean?
That's all I got.
It's the half.
No, the new time. That's an example here. It's
It's
not.
just half.
What kind of an example? Okay, let's remove this example. Has nothing to do with anything, any Q or any time is the same. Q over 2. The holding cost, what does holding cost mean? Which means, what's your total holding cost if you count every day for 365 days and you add them together, that's your total holding cost, right? That is not the smart way to calculate holding cost. The idea is that's the way, right? Every day you count, okay, how many items are on hand? 100 items, and then you times H divided by 350, because H is the annual holding cost. That's for day 1. Day 2, you count how many items are on hand, and you times H divided by 365. You know, okay, day 2, we charge a holding cost. Day 3, until 365 days, you know that is the total holding cost. You can same result with Q over 2 times H. The reason is that the smart way to calculate holding cost is not just count how many items per day. You want to count the average how many items per day, right? And then times the annual holding cost, you direct get that. What's the average inventory level?
Q plus 0?
Q over 2. Average inventory is Q over 2. Do you agree with me?
Why?
Why? Okay. You don't agree. Okay. Anybody agree with me? The average inventory level is Q over 2. Anybody agree with me? Nobody?
I mean,
Nobody agree with me.
I'll agree with you.
I want to ask you, cameraman, why you think it's Q over 2
Maximum minus minimum.
divided by 2?
Yeah.
Right? As cameraman said, maximum is Q. When every time you place the order of Q, right, you receive that when you have 0 inventory. So your maximum inventory level is Q. It's the same as your order quantity, right? Your minimum is 0. Why it can divide by 2? Because it's a straight line. We have even demand. If it's a curve, we can't say it's just maximum minus minimum divided by 2. But it's even, we know that it's happened that the average demand is Q over 2. We can see this here. Look at the first triangle, right? The inventory level is average Q over 2. Agree? From Q to 0 with a straight line, average Q over 2. Agree with me? Right? Jack, now agree with me? No?
Yeah.
Okay. So now we explain why is Q over 2 times H, because you can see no matter how frequent you order, doesn't matter. It just happen again and again. This triangle happen again and again in this per year. So each triangle, each cycle, we have the average inventory level is Q over 2. So per year is the same. Even per 10 years, still Q over 2. And the H is the annual holding cost per unit. So that means Q over 2 is your 1 year's average inventory level times holding cost per unit per year, which has your annual holding cost. It's Q over 2 times H. Clear for you? Kind of, okay. Take some time. The next one is kind of easy. Now we know that annual holding cost is Q over 2 times H. Last cost is the ordering cost. Since this inventory can't come from nothing, we have to place order, right? We have to place order to our supplier. Every time when we place order, we have a fixed cost, which is called S. It's the ordering cost per order. No matter what's the amount you order, 1,000 units, 100 units, the same amount, same order. Think about it, can be a transportation fee, a package delivery, doesn't matter how many you, how heavy of the package that it has the one-time ordering cost. D over Q. Who can tell me what does D over Q mean? D is the annual demand. D is the annual demand. Q is your per ton order quantity. Then what does D over Q mean? Annual demand divided by your order quantity. Let's say your annual demand is 1,000. Your order quantity is 100.
How many times you have to make an order?
That's great. So it's your annual order times, right? How many times you place order per year, right? Then times S, right? It's per time order cost, which means your annual order cost here. That's kind of easy to understand, right? If you have 1,000 is your demand per year, 100 is order quantity. 1,000 divided by 100 is 10, which means you have to order 10 times per year. Every time, let's say you have $10 cost, so it's 10 times 10, which is 100, is your annual ordering cost. Okay. Now, we have to understand the formula because I will not ask you guys to understand how to solve this equation. But as a business student, we have to understand the formula. Otherwise, if manager asks you, okay, client, why this is holding cost? You say, okay, Charles told me. Who is Charles? Nobody knows, right? You say somebody else, okay. They can't buy that. If you are a school business, you are a business person, you have to understand, okay, this is holding cost, this is ordering cost. Last step is also requiring school business, okay. We'll get the solution, okay. Let's explain here. Because the holding cost is a straight line, it's a linear function of Q, right? Given H is a linear function of Q, right? The slope is H over 2. And the ordering cost is a curve because Q is in the denominator position, right? So it's a curve. And the red line is the total cost. You can see here, when the Q increase, which means you order more every time, you have a higher holding cost. Understandable, right? So if you order 10,000 units, then you really take a long time to consume all the stock, and then you have a higher holding cost. But on the other hand, if you order more, or if your order quantity is higher, you have less ordering cost because probably you only need to order once per year, but only one time charge ordering cost. That's why these two have two different directions. Adding together is the red line, which has the optimal points to minimize this total cost. That's how you get the optimal order quantity, EOQ points. Using calculus, you can see here in the business school, it's very easy for us. Make our life easy, just say, using calculus. Less people do that, right? And then we take the derivative of the total cost function and set derivative slope equal to 0 and solve for Q. Who understand that? I don't expect anybody to really solve for me, but who understand? Who can explain the first bullet for us? Using calculus. Anybody understand that?
Well, sort of. I mean,
Mhm.
the derivative is pretty much
Which variable we should take a derivative? There are so many Q, H, S, D. Which variable we should take a derivative? Q, great. Because Q is a variable we want to solve, right? All other is not variable, should be parameter, or should guess the input here. So we take the derivative of Q, which is not easy, right? It's not hard, but it's not easy.
with the derivative of Q would be that straight line, right?
But the first part is, in fact, H over 2 because it's the linear function. But second part is the harder part, take the derivative. Because in the
Okay.
denominator. Right? I think Cameron should be able to solve this, right? From engineering school. I do have one student last semester, he really solved that in class. He's very confident. He solved that and showed me that it's really real. But it's not required. If you really want to review a calculus, please do this example in the full break, right? Keep it up, right? Get this solution. You take the derivative of the total cost function for Q and set is equal to 0. You solve that, you will get Q0 equal to square root 2ds divided by H. That's the optimal Q. Because we know that when we set the first derivative equal to 0, the guarantee we can get optimal order quantity. That's the math way. Right? But I don't think clients will ask you that. How can you take it? But as long as you understand, it's fine. We don't require that. Okay. I remember the first time I was teaching the Purdue for the business statistics in the management school. Because I only transferred from my applied math PhD program from Minnesota to Purdue like in the third semester. I'm still like kind of a math person. So when I was teaching the business statistics, you know the least square method, right? When you calculate the B and A for the linear function, y equal to b plus ax, whatever. We know that we have the formula we introduced in chapter 3. I explain to students why is the formula. In fact, we use least square to minimize the square similar derivative and so that we get A and B. And the student just copy whatever I write. For 10 minutes, I told them, okay, it won't be test in the exam. Everybody hates me. Because they spend 10 minutes to write this down. They don't want to understand why we can get A and B. So, and then from then on, I never taught about how to solve the calculus in the business school. But we should know that, right? So that's the purpose. So, explain, Jack?
Can you not just can you go back to the slide before? So there, it's just the minimum point, right? So if you graph that line, that equation, that line, you just take the minimum of it. Aren't you doing this?
Very good point. But if you graph a line, how can you guarantee this point is minimum?
Your calculator.
Still use the calculus. Because it's a line. You say, okay, it's 45. I can argue it's 45.5. You say 45.3. I can argue it's like 45.4. You can argue for error, right? Because you can know the range, probably the range of the minimum point, but you can't really tell the exact point. Agree, right? Only by the calculation, you can tell me the exact point. But that's good. You should draw the picture. You should draw the picture. Make sure you won't make a mistake. If your final calculation is far away from this point, you know there must be something wrong. Catherine?
Must there not be a minus before
Which is minus?
next?
Next slide.
Yeah.
Which?
I get it.
Okay. Any
Is it
Question?
If it was minus,
No?
it would be a math.
Yeah.
Okay. Final question for today's class. We don't have to understand how to get this one, but if I'm a client, the last Chinese question I ask you, okay,
I see.
I trust you, but let's see this formula. 2ds divided by h square roots. If the annual demand increase, what happened for the optimal order quantity? If D increase, where the optimal order quantity increase or decrease? Increase, right? Because D is in the numerator position. Explain to me. Why, if my product is very popular, our annual demand increase, why every time I should order more? Does this make sense? Make sense? Does it make sense?
You said every time you should order more just because the demand for your product increases.
Because this the formula told us. If we trust this formula, your demand increase, your optimal order quantity also increase.
I don't think you should always.
You don't think you should?
I don't
Okay.
think you should always.
Because doesn't your holding cost also increase?
Your holding cost, right?
The more you order, the holding cost
That's
also.
right.
And then you could also just be.
But on the other hand, very good thoughts. But on the other hand, your ordering cost, you think about it, if your demand increase dramatically, right? If you keep the same amount of order quantity as before, you have to order more frequently. Agree? Right? If your demand triple, you still order the same order quantity per time. Then you should order more frequently because the daily demand triple. Right? Then you will increase your ordering cost because you order too frequently. How to balance that? You increase the order quantity a little bit. That's why when demand increase, our optimal order quantity Q also increase. Second, S. When ordering costs increase, right? S order. When ordering costs increase, will the optimal order quantity increase or decrease? S increase. What about Q? Increase or decrease? Increase, right? Because S is also a numerator. Why? Why S increase? We should also increase our order quantity. What is S?
Supply.
What's order? S is the ordering cost. Good guess though. S is ordering cost. You think about it, if ordering cost is extremely, it's very, very high. It's what, $10,000 per time. What you want to do? You order less frequency as possible, right? You every time I charge $10,000 to place order, I'll place one order for 10 years if I can, right? then which means you have a huge order quantity. Extreme case. So you understand, if your order cost per time increase, you should order less frequently, which means your order quantity should increase. Right? The last question, holding cost increase, H increase. What about Q? Increase or decrease?
Decrease.
Decrease. Yeah, because it's a denominator. Why the holding cost increase? Then we should decrease our order quantity.
If it decreases, then it will increase. So you should increase your order quantity.
Yeah, I know from mathware. Business sense. Why, when the holding cost increase, why we should order less?
Because it's gonna become too expensive for you to hold that inventory.
Finally, you got the correct answer, Bernard, at the end of today's class. When you have a higher holding cost, think about extreme case, Sam, still. $10,000 per unit holder your unit. What should I do? Probably you want to get rid of unit as soon as possible, right? I would place order every day. I want to place order every day to get 0 unit, extreme case. So if the holding cost is really huge, our order quantity is small because we don't want to hold a lot on hand. Instead, we want to order more frequently. So you can see, make all this scenario make sense for the business person. We don't know whether this is make sense. If you have time in the formula, you calculate that. But we can kind of trust this formula because it makes sense, right? Every time DSH change is corresponding to our common sense of business. So kind of trust that. That's my understanding. We don't require for student you to understand the formula, but we need to understand the scenario, okay, if scenario of this formula makes sense. Okay, that's the end of today's class. Enjoy your fall break, and I need to give you a case study back.